Hey, 20-1s. Welcome to your lesson on arithmetic series. So what we've been talking about the last few lessons has been a sequence. So what's the difference between a sequence and a series? Well, all a series is we're going to take a sequence and we're going to find the sum of it. That's all it is. So the word series means we're adding or summing the entire sequence up. All right, so our notation for this, we're going to use S sub n. Makes sense, right? Sum of the series, S sub n. And so all we'll do to our sequence is you notice is that we're going to put plus signs in between and we'll add it up all the way to whatever our last term is. So if we wanted to find the sum of the first 50 terms, we put S sub 50 and we go all the way up to that 50th term, just like that. So, I mean, it makes sense. The notation is easy to figure out. Now, there's two different formulae for this section, so that sometimes causes students some confusion as to which one to use and when. These are both on your formula sheet. I'm not going to prove them to you now, but you need to know these. Okay, here's your first one. N times parentheses the first term plus the last term, and we divide it all by 2. Your second one, which is really just a slight variation of this first one here, is this, n times brackets. I'm going to put brackets there. I like brackets on this one because we've got these parentheses there. And again, all divided by 2. Okay, so like I said, I'm not going to prove them to you, but those are your two that are on your formula sheet, and where we know S means the sum, N is the number of terms that we're working with here. T1 we know is our first term, and if you ever come across it, like some people call the first term A, so you might see that at some point, and then Tn is that last term, right? So when am I going to use each of these two different formulae then? That's the question. Well, look at the difference between these two. In this first one here, what do I need to know? Well, I need to know the first term and the last term. So I'm going to use this one when I know the first and the last. Okay, that makes that question really easy. If we compare that to the second formula here, do you notice in the second formula, we don't know the last term? What we know here, which is different, is we know the difference. So I'm going to use this one here when I know the difference. Okay, just like that. So every time you're going to look at your formula sheet, and you're just going to kind of piece together what it is you know and what it is you're trying to find. Okay, let's do a couple of these. You'll see that to me, it's easy because it's just a formula and I'm just plugging numbers into a formula. I like that. So example 1, given this series, let's find the sum of the first 50 terms. Okay, so which formula am I going to use? Well, I'm just going to scroll back up here. I'm going to do my little check that I wrote in purple here. Well, do I know the last term? No. So I'm going to use the second formula. And again, please always write your formula down. Okay? It's not like you get a mark for writing it down, but if you screw something up, at least your teacher knows what you were trying to do. Okay, so right there, I made a small mistake, but let's fix it. Okay, so there's your formula, right off your formula sheet. Okay, now what I like to do when I'm doing these questions is it never hurts to write down your variables off to the side. So I want the first 50 terms, so n is 50, t1 is the first term, and the difference, well, I can tell the difference just by looking at it. From each term to the next, we're going up by 4. So now, friends, all you do is just sub in these values. Okay, now from here, if I see a mistake, it's usually just students or just putting too much in their calculator at once. Okay, so I don't suggest you pick up your calculator and just start ramming everything in at this point. Slow down, right? You figured out the question. You don't want to make a silly mistake. Okay, what I'm going to do here is I'm going to say 50 divided by 2 is 25. 2 times 3 is 6, plus 49 times 4. And so instead of me trying to do everything at once, I'm just going to slowly keep simplifying. Okay, I'm going to simplify inside my brackets here. That'll be 202. And now I simply just multiply these together, and I get 5,050. There it is. The sum of the first 50 terms was 5,050. So again, what did I do? Well, I analyzed what is it I know. Well, I don't know the last term, but I know the difference. So that's why I used that formula. Okay, let's try another one. Given the series, determine S 100. Okay, so once again, I don't know that last term. So all I'm going to do here is I'm going to use the same formula again. And as you kind of go through this unit, you start to memorize the formulae. You know, what are our values? Well, we want the first hundy, so that's 100, right? T1, well, I can see that's 2004. The difference, well, the difference will be negative here because we're going down, right? And again, remember, if you wanted to find the difference, you take any term, doesn't matter, I'm going to choose 1920, and you subtract the previous term. So what I can see then is my difference is negative 42. So remember, if you want to find the difference for anything, you take any term and you subtract the previous term. It's going down, so I know it has to be negative. Okay, and now all we do is we just carefully sub in the values. Okay. And I don't want to skip any steps here. So even that step where it's 100 minus 1, okay, I really want my teacher to see what I'm subbing in, okay, just in case I make a mistake, and slowly do this. 100 divided by 2 is 50. 2 times 2004 sounds like 4008 to me, plus 99 times negative 42. Now, yes, I'm absolutely picking up my calculator at this point. I have no idea what these numbers are, but let's just do it. So inside the brackets there, 4008 plus 99 times negative 42, that's negative 150. And now multiply that by 50. S 100, so the sum of the first 100 terms is negative 7,500. So it's okay to have a sum that's negative. What that means is there's more negative terms in our sequence or our series than there are positive terms. That's all that means. Okay, let's try another one. Last one. Determine the sum of this sequence. So when I'm analyzing this, what I notice is different is on this one, I know the last term. So I'm going to use the other formula. So Sn is equal to n over 2 T1 plus Tn. Okay, I know the last term. So off to the side here, let's start writing stuff down. Well, I know T1 is 13. I know Tn is 49. Okay, but I need n. Ah, crap, I don't know n. So what am I going to do? Well, to find n, what we're going to do is we're going to revert back for a second. If I want to find n, we're going to revert back to our formula for arithmetic sequences, which is this. So sometimes we have to go back to sequences for a minute because this really is a sequence, and then sub in the values to find n. Well, in this one, Tn we know is 49, T1 is 13, n is what we're looking for, and the difference, well, again, I can look up here and say the difference is 2. Now I'm going to just isolate for n, so that's 36, n minus 1 times 2, divide by 2, so n is 19. Okay, now I know that. Now I can answer this question. So let's go back to pretty blue here, and let's answer this question. So don't be surprised if, when you're doing these questions, you have to go back to something you learned in a previous lesson. Okay, first term is 13, last term is 49, divided by 2. And again, all we want to do here, friends, is just slow down. Don't make a silly mistake at this point, right? 13 plus 49, what's that, 62 over 2. And S19, like I'm trying to pick up my calculator as little as possible. And now I'm going to just put that in my calculator. 31 times 19, that sounds like 589. There it is, friends. Okay, so you know your two new formulae for finding the series of an arithmetic sequence. It's just which one do you apply? Good luck to you. I will see you next time.